Have you ever looked up at the night sky and wondered about the clusters of stars? Each tiny speck of light, a part of a grand celestial tapestry, tells a tale of cosmic proportions. These clusters, scattered across the universe like diamond dust, are more than just pretty constellations. They are the cornerstone of our understanding of the cosmos, key to unlocking the secrets of stellar evolution, the formation of galaxies, and the enigmatic dark matter. Star clusters, both open and globular, are not just groups of stars, they are cosmic laboratories. They stir the human imagination, challenging us to ponder the vastness of our universe and the complex laws that govern it. They are the celestial puzzle pieces that help us piece together our cosmic story, a story of birth, life, and death on a cosmic scale. So are you ready for a grand cosmic adventure? Come along as we delve into the top 10 key findings from the study of star clusters. What exactly are star clusters? The answer to this question takes us on a journey millions of light years away from our humble home planet into the vast, uncharted territories of the cosmos. Star clusters, in their simplest form, are groups of stars that share a common origin and are gravitationally bound to each other. A celestial dance, if you will, with stars swaying to the rhythm of cosmic forces. There are two main types of star clusters: open clusters and globular clusters. Open clusters, also known as galactic clusters, are loosely bound collections of stars. They're relatively young, often adorned with glowing gas and dust from the nebula from which they were born. These clusters can contain anywhere from a few dozen to a few thousand stars, and they're primarily found in the spiral arms of galaxies, like our own Milky Way. On the other hand, globular clusters are tight groups of hundreds of thousands, sometimes even millions, of old stars. These celestial orbs are densely packed and usually spherical, hence the name globular. They orbit around galaxies in a halo, far from the galactic center, like bees buzzing around a hive. The formation of star clusters is a fascinating process. It begins with a gigantic molecular cloud in space, which, under the influence of gravity, starts to collapse. As the cloud collapses, it fragments into smaller clumps. Each clump continues to collapse, and as it does, it heats up and forms a glowing ball of gas, a new star. When this happens to thousands or even millions of clumps in the same area, a star cluster is born. Star clusters play a pivotal role in the stellar life cycle. They not only give birth to stars, but can also be their graveyard. Stars in a cluster evolve together, and their fate depends on their mass. The most massive ones explode as supernovae, leaving behind neutron stars or black holes, while the less massive ones end their lives more gently as white dwarfs. Understanding star clusters gives us crucial insights into the workings of our universe. They're the cosmic laboratories where we can study stellar evolution, the formation of galaxies, and even the mysterious dark matter. So, buckle up as we dive deeper into the cosmos, exploring these celestial wonders. One of the most important findings is about stellar evolution. Let's delve into this captivating discovery that has reshaped our understanding of the cosmos. By observing star clusters, scientists have been able to chart the life cycle of stars. From their fiery birth, through their radiant adolescence, to their eventual death, each stage of stellar evolution is represented within these celestial gatherings. Much like how a tree's rings tell the story of its life, star clusters reveal the chronicles of stellar evolution. Each cluster is a snapshot of a specific moment in time, allowing us to understand how stars change and evolve. Through these clusters, we've discovered that stars, much like us, have a life cycle. They're born, they mature, and eventually they die. In essence, star clusters serve as cosmic laboratories where we can study stars at different stages of their lives, all in one place. This finding has dramatically improved our understanding of the life cycle of stars. Star clusters have also enlightened us about the formation of our own galaxy, the Milky Way. It's like reading a cosmic history book, with each cluster offering a unique chapter. The youngest clusters tell us about our galaxy's recent past, while the oldest ones provide a glimpse into the early universe. The Milky Way is a barred spiral galaxy, a magnificent swirl of billions of stars, gas, and dust. But how did it take this form? By studying star clusters, we've discovered that galaxies form from the inside out. The oldest star clusters, globular clusters, are found in the galaxy's halo, which formed first. Younger open clusters are found in the spiral arms, revealing later stages of galaxy formation. These clusters, like cosmic breadcrumbs, have also helped us trace the Milky Way's spiral structure and even its size. They've illuminated how galaxies evolve, change, and grow over billions of years. In essence, star clusters are the building blocks of galaxies. Here's a mind-bender. Star clusters have also helped us map the invisible, dark matter. Now you might be asking, what's dark matter? Well, it's a mysterious substance that we can't directly see or touch, but we know it's there because of the gravitational effects it has on visible matter in the universe. So, how do star clusters help us understand this elusive substance? The answer lies in their gravitational pull. You see, the gravity of a star cluster can warp the space around it, causing light from distant galaxies to bend as it passes by. This effect, known as gravitational lensing, can give us clues about the amount and distribution of dark matter in and around the cluster. By studying these gravitational distortions, astronomers can create maps of dark matter distribution across the universe. It's like using a cosmic magnifying glass to reveal the unseen. It's through star clusters that we've been able to see the unseen. Star clusters have also been instrumental in measuring the age and distance of celestial objects. They are, in essence, celestial timekeepers, holding the secrets of cosmic chronology. By observing the brightest and dimmest stars within a cluster and comparing their luminosities, astronomers can estimate the cluster's age. This process, known as main sequence turnoff, is a crucial tool in understanding the timeline of the universe. Let's delve into the details. When a star exhausts its hydrogen fuel, it veers off the main sequence in a Hertzsprung-Russell diagram and becomes a red giant, which is brighter but cooler. The point at which stars begin to turn off reveals the cluster's age. The older the cluster, the more stars have turned off the main sequence, and hence the brighter the turnoff point. Now, what about the distance? Well, star clusters are like cosmic yardsticks. By comparing the apparent brightness of cluster stars to their known absolute brightness, astronomers can calculate the distance to the cluster using a method known as the distance modulus. This technique is incredibly valuable because measuring cosmic distances is notoriously challenging. But that's not all. Star clusters are also cosmic laboratories, offering insights into the composition of celestial objects. By studying the spectrum of light emitted by stars within a cluster, scientists can determine the elements present within those stars. This is due to each element having a unique spectral signature. For instance, helium lines in the spectrum indicate the presence of helium in the star. These spectral signatures also help us understand the chemical evolution of the universe. We can track the increase of heavier elements over time, a process known as metallicity. Higher metallicity indicates a younger star, as heavier elements are formed from the nuclear fusion in previous generations of stars. So, star clusters are not just magnificent to behold, they are key to our understanding of the universe. They allow us to measure cosmic ages, distances, and compositions. Without star clusters, many cosmic measurements would remain a mystery. The final three key findings center around stellar populations, gravitational lensing, and exoplanets. Let's dive in. Stellar populations are essentially the different generations of stars. Star clusters, like celestial family reunions, bring together stars of varying ages, sizes, and compositions. This provides a unique opportunity to study the life cycle of stars in a concentrated area. For instance, globular clusters, typically older, house stars that are as old as the universe itself. Open clusters, on the other hand, are usually younger and contain stars that are relatively new additions to the cosmic family. The diversity within these clusters gives us invaluable insights into the evolution and lifespan of stars. Next up is gravitational lensing, a phenomenon predicted by Einstein's theory of relativity. When a massive object, like a star cluster, lies between us and a more distant light source, it bends the light from the source around it. This creates a lens effect, allowing us to see objects that would otherwise be too faint or distant. Star clusters, particularly globular ones, have been key in providing evidence for gravitational lensing, further validating Einstein's theory and offering us a unique tool for observing distant galaxies and cosmic phenomena. Lastly, we reach the intriguing world of exoplanets. These are planets outside our solar system, orbiting around stars other than our Sun. The dense packing of stars in clusters increases the likelihood of spotting exoplanets. By studying the tiny dips in the light of a star when a planet passes in front of it, called a transit, we can identify and study these distant worlds. Star clusters offer a concentrated area where these transits can be observed, making them prime hunting grounds for finding new exoplanets. These are just a few examples of how star clusters continue to shape our understanding of the universe. So, why does all this matter, you might ask? Well, the study of star clusters isn't just a pastime for astronomers. It's a key to understanding the universe, its history, and our place within it. Let's take a step back and summarize our key findings. We've learned that star clusters, both open and globular, are crucial for understanding stellar evolution. They provide a snapshot of stars at different life stages, all born from the same cosmic material and at roughly the same time. This allows us to observe a star's life cycle in a way that would be impossible with individual stars. Next, our understanding of the formation of the Milky Way has been significantly shaped by studying star clusters. These clusters, especially globular ones, are some of the oldest structures in our galaxy. They serve as living fossils, providing clues about the early conditions of the Milky Way and how it has evolved over billions of years. The distribution of dark matter, the mysterious substance that makes up about a quarter of the universe, also comes into clearer focus when we study star clusters. Their motions and distributions give us indirect evidence of dark matter's presence and how it's spread throughout the cosmos. Furthermore, by studying the age, distance, and composition of star clusters, we've been able to refine our cosmic distance ladder, estimate the age of the universe, and understand the chemical evolution of galaxies. Lastly, our findings about stellar populations, gravitational lensing, and exoplanets in star clusters have broadened our understanding of how stars and planets form and how gravity can bend light, providing us with tools to observe the universe in unique ways. In essence, star clusters are like miniature laboratories, offering a window into the past, present, and future of the universe. They help us piece together the grand cosmic puzzle, enriching our understanding of the celestial tapestry and our place within it. The study of star clusters is not just about stars, it's about understanding the universe and our place within it. What does the future hold for the study of star clusters? As we journey into the future, the study of star clusters promises to unlock even more cosmic secrets. With advancements in technology, we're likely to witness a surge in discoveries and insights. The next generation of telescopes, for instance, is set to provide unprecedented views of distant star clusters, shedding light on their formation, evolution, and eventual demise. With this, we might uncover the secrets of stellar life cycles and the mysteries of dark matter distribution. Furthermore, as our understanding of exoplanets grows, star clusters could offer clues to the existence of other habitable worlds. Imagine star clusters potentially serving as cosmic signposts to alien life. Advancements in artificial intelligence and machine learning could also revolutionize star cluster research, enabling us to sift through vast amounts of data with greater speed and accuracy. The universe is vast and full of mysteries, and star clusters will undoubtedly continue to play a key role in unraveling them. As we gaze up at the night sky, we are looking at a cosmic jigsaw puzzle. Each star cluster, whether open or globular, holds a myriad of clues about the nature of our universe, from the intricacies of stellar evolution to the formation of the Milky Way, and even the elusive distribution of dark matter. Our journey through the 10 key findings from the study of star clusters has only scratched the surface of this vast, complex puzzle. Each piece we uncover leads us to more questions, more mysteries, and deeper understanding of our place in the cosmos. So let's continue to wonder, to question, and to explore. For in the heart of every star cluster lies a story waiting to be told, a mystery waiting to be solved. As we continue to piece together this cosmic jigsaw puzzle, let's remember one thing. Remember, every star cluster you see is a piece in the puzzle of the universe. As we wrap up our interstellar expedition, we encourage you to join us in this deep space exploration. If you've learned something new from our journey across the universe, show your appreciation by giving this video a like. Your support fuels our mission to unlock the enigmas of the cosmos. Always remember, the universe is an expansive, unscripted narrative, and are all scholars with an insatiable curiosity. So, we're intrigued to know your thoughts. What fascinated you the most about the star clusters? Do you have any hypotheses or queries related to this topic? Leave your opinions in the comments section, and let's continue this intellectual discourse. Moreover, if there's anyone in your friends or who may be interested in this cosmic venture, feel free to share this video with them. The more intellects we have investigating the universe, the closer we come to solving this celestial conundrum. As we bid farewell, remember that every star in the sky has an untold tale. So never stop looking up, never stop wondering, and above all, never stop exploring. If you haven't already, don't forget to subscribe and hit the bell icon for more enlightening content. Until our paths cross again, fellow cosmic voyagers.